Hello everyone. In our previous videos, we discussed the Newton's first law of motion, which is known as the law of inertia, which says that an object at rest or in motion remains at rest or in motion unless acted by an external force. In this video, we will be discussing the relationship of the force to acceleration, and this is what we call as the law of acceleration. It says that the acceleration of an object is directly proportional to the net force and inversely proportional to its mass. Or mathematically, we can say that the sum of all forces is equal to mass times acceleration. And as we can see, as the force increases, the acceleration increases. Say, for example, suppose we consider this box with a mass m, and we exert a force to move this box having a speed of v. If we exert a constant force to this box with, say, 100 kilograms, and it moves at a speed v, and compare it to a box with a mass of just, say, 50 kilograms, we can say that the box with a lighter mass moves faster as compared to this heavy box. The same as well happens if we maintain the mass of the box to 100 kilograms, for example, and at first we apply a force F to move this box. Now we compare it to a box where we exerted a force that is 2 times the force in the previous scenario. Of course, the box will move faster. And that is what we mean by saying the force is directly proportional to the acceleration. Also, from this equation, we can see that the acceleration is inversely proportional to the mass. We have the acceleration is equal to force over the mass, which means that as the object becomes heavier, the acceleration becomes smaller, and thus the speed becomes smaller, or the speed decreases. Now let us try to solve this example to see or to have an application of this Newton's second law of motion. An ice boat is at rest on a frictionless horizontal surface. A wind is blowing along the direction of the runners so that 4 seconds after the ice boat is released, it is moving at 6 meters per second. What constant horizontal force does the wind exert on the ice boat? The combined mass of ice boat and rider is 200 kilograms. So to solve this problem, it's always better if we can draw what happens to this scenario, or if we can draw the system. Now suppose this is our horizontal surface, and of course from the problem, this is a frictionless horizontal surface, and suppose this is the boat. Anyway, this is just a rough drawing, no? Suppose this is the boat, and we have here the person inside the boat. And then suddenly, a wind blows with a force which we can denote as Fw that goes towards the wind. Now, what are the forces acting on this boat? Basically, the boat has a mass, and the combined mass is 200 kilograms. So we have here the weight, which is equal to mass times acceleration. And as we know, the acceleration due to gravity is equal to 9.8 meters per second squared. And here from the problem, we have the mass total is equal to 200 kilograms. We can see here as well that there is a surface of contact between the boat and the horizontal surface, which means that we have a normal force. And of course, with respect to the x-axis, since this is frictionless, so there is no other force, or there is no friction force acting on this object. So we draw here the free body diagram. We have the free body diagram. As we know, a free body diagram is, of course, a free body diagram, or a diagram in 2 dimensions, which shows the relationship of the forces, or the magnitude and direction of the forces. This is, okay, anyway, this is just a rough drawing. So from here we can see that the normal force is upward, So this is the normal force. We have the weight. Let me just draw this properly. We have the weight is downward, and we have here a force pointing to the right, which is the force due to the wind. Of course, there is no force pointing to the left because there is no friction. So let us try to solve this one. As we can see, the boat moves horizontally with a speed v is equal to 6 meters per second. So obviously, there is no motion with respect to the y-axis, which gives us the sum of all forces with respect to the y-axis is equal to, okay, what are the forces? This is the normal force is positive because it's pointing upward. And we have the weight is negative because it points downward. So we have N minus W. And this is equal to 0, again, because there is no motion with respect to the y-axis. And this directly gives us N is equal to weight, which is equal to mass times gravity, because the weight is equal to mass times gravity. Now, how about the forces with respect to the x-axis? So we have the forces with respect to the x-axis. As we can see, there is only one force, and that is the force due to the wind. So this is equal to the force exerted by the wind on the ice boat. And as we can see, there is a motion with respect to the x-axis after the wind exerted a force. So this is equal to mass times acceleration with respect to the x-axis. So as we know, the mass is equal to 200 kilograms. So this implies that the force of the wind is equal to 200 kilograms times the acceleration, which is unknown. So we still have to solve for the acceleration for us to be able to solve for this force due to the wind. So from this problem, we can see that the velocity or the speed, or initially the ice boat is at rest. So we can say that the initial velocity is equal to 0, or the initial speed is equal to 0. And then when the wind blows this ice boat, it gains a speed of 6 meters per second. So we can say that this is V2, and this is equal to 6 meters per second. After time t is equal to 4 seconds. So to solve the acceleration, we can use the kinematics equation, which says that V2, or the final speed, is equal to V1, which is the initial speed plus the acceleration with respect to the x-axis times time. So we can directly solve for the acceleration, which is equal to, we transpose this one to the other side and then divide t to both sides. So we have V2 minus V1 over t. This implies that the acceleration with respect to the x-axis is equal to, what is V2? Of course, this is 6 meters per second minus what is V1. This is equal to 0 because this is initially at rest, divided by the time, which is 4 seconds. Okay? So this gives us the acceleration is equal to 1.5 meters per second squared. Now that we know what the acceleration is, obviously, we can solve for the force exerted by the wind. So we have the force exerted by the wind is equal to, this is again 200 kilograms times the acceleration with respect to the x-axis, or this is equal to 200 kilograms times, we have 1.5 meters per second squared. Thus, the force due to the wind is equal to, this is 300 kilograms times meters per second squared. But we define here a unit which says that 1 kilogram meter per second squared equals 1 Newton, or this is denoted by 1 capital N. Therefore, the force due to the wind or exerted by the wind on the ice boat is equal to 300 newtons. And we have to take note here that Newton is the unit of force. This is the unit of force. Okay, so if you have questions regarding this problem or regarding this topic, you may just comment on the comment section. Now let us try to solve this example. Suppose a 70 kilogram box is pulled by a 400 Newton force at an angle 30 degrees to the horizontal. The coefficient of sliding friction is 0.5. Find the acceleration of the box. Okay, so we have here, okay, so this box is pulled at an angle of 30 degrees. So let us just draw this one. This is 30 degrees with respect to the horizontal. Suppose this is F. And of course, as we know, this has a mass, which is 70 kilograms. So we also have here a downward force, which is the weight. And this is equal to mass times gravity. Still, the value of gravity is 9.8 meters per second squared. We also have here the normal force, pointing upward because there is a surface of contact. Okay, so we have here the normal force. And according to this problem, the coefficient of sliding friction is 0.5. So basically, we also have here a friction force. Okay, we have the friction force here. Okay, so of course, since this is moving or this is sliding, so we can see that this is a kinetic friction force, which as we know is equal to mu sub k times the normal force. So to solve this problem, it's better if we have a free body diagram. So we have here the free body diagram. Okay. So what are the forces with respect to the y-axis? We can see that there are, okay, the obvious are the two forces, normal force. We have the normal force and we have here the weight. But actually there is a third force with respect to the y-axis. And that is the component of the force or the applied force with respect to the y-axis. As we can see, the applied force here is 30 degrees with respect to the horizontal, which means that there are components with respect to the x-axis and the y-axis. So we can just draw it here, that this is the component of the x or of the force with respect to the x-axis. And we also have here the component of the force with respect to the y-axis. So basically, there is an additional force here in this free body diagram. Okay, and this is, let me just draw first the original force. This is the force, the exerted force, which is at an angle of 30 degrees. But of course, there is a component here with respect to the x-axis, and there is also a component here with respect to the y-axis. And the final, or the last and final force that is available in this problem is the kinetic friction force, which points towards the left. Because as we know, if the force exerted is pointing towards the right, the friction is a resistive force that opposes the motion or the attempted motion. So basically, it should be pointing towards the left. So this is our kinetic friction force. So still, there are forces, or there are two mathematical equations that are useful for this. The first one is the equation with respect to the y-axis, and we have the equation with respect to the z-axis, or to the x-axis. So we start with the equation with respect to the y. So we have the sum of all forces with respect to the y-axis. Obviously, there is no motion with respect to the y because the box doesn't move vertically. So this is equal to, okay, we have Fy, the component of the force with respect to the y, minus the normal force, which is positive, and we have minus the weight. And this is equal to 0 again because there is no motion with respect to the y-axis. And from here, we can solve the normal force. Okay, we have, this implies that the normal force is, we just have to transpose this to the other side of the equal. So this is equal to the weight. This is negative. So after transposing, this will be positive. So you have weight plus the force with respect to the y-axis, minus. Let me just erase this one. Eraser. Okay. Okay, that's it. So we have Fy is positive, so after transposition, this will be negative, so this is minus Fy. But what exactly is Fy? As we can see from this figure, Fy is the opposite side of this triangle, which means that N is equal to W minus, what is Fy? This is F, opposite, so this should be sine. So we have sine of 30 degrees. And from the problem, the force is given, which is 400 newtons. So we have the normal force is equal to the weight, which is mass times gravity. Okay, this is mass times gravity. But what is the mass? That is 70 kilograms times gravity, which is 9.8 meters per second squared, minus, we have F is 400 newtons, and sine of 30 degrees is 1/2. So this is times 1/2. Or we have the normal force, okay, is equal to what is 70 times 9.8. This is 686 newtons minus 400 times 1/2. That is just equal to 400 divided by 2. So this is 200 newtons, which gives us the normal force is equal to 486 newtons. So now that we are done with the calculation of the forces, particularly the normal force with respect to the y-axis, we should be calculating the forces with respect to the x-axis. Okay, so we have, from the free body diagram, there are two forces in the x-axis. These are the forces. Okay, we have Fx, which is the component of the force with respect to the x, and we have the kinetic friction force. So we can just write it here. We have the sum of all forces with respect to the x-axis is equal to, this is Fx is positive. Okay, so we have Fx minus Fk, which is negative because it's pointing towards the left, and this is equal to mass times the acceleration with respect to the x-axis. The question is the acceleration. So of course, this is very straightforward. So we have the acceleration with respect to the x-axis is equal to, this is Fx minus Fk over m, or this is equal to, what is Fx? This is basically from this triangle, the adjacent side, so this is cosine. Okay, so we have here 400 newtons, cosine of 30 degrees. Let me just extend this one. Minus Fk is mu sub kn. No? This is mu sub k times the normal force, but mu sub k is 0.5, so this is 0.5 times the normal force, which is 486 newtons, and this is divided by mass, which is 70 kilograms. And this gives us the acceleration is equal to 1.47 meters per second squared. So this is now the acceleration with respect to the x-axis. So if you have questions regarding this topic or regarding this problem, you may just comment your clarifications or questions in the comment section. Thank you very much.